Alright, so this is section 1.5. Here we're going to talk about solving linear equations and some applications of linear equations. Alright, so this is the first part of this video. In the first part we're just going to be solving some equations and talking about the details of solving the equations. In the next part we will be solving some application problems. Alright, so if you are trying to solve an equation for one variable, right now we're only going to have one variable involved. There's going to be either just one x or one t or whatever the variable is called, but there's only going to be one variable, not two. If you're trying to solve an equation and the variable gets eliminated, so imagine all of the variables all of a sudden cancel each other out and you end up with a situation with a number not equal some other number. So for instance, 3 not equals 3. Then that means that your original equation did not have a solution. Now, if you end up with something like 3 equals 3, then that's going to mean that you have infinitely many solutions. Yeah? So keep that in mind. If you're solving these equations and all of a sudden all of your variables cancel and you end up with something like 3 not equal to, or for instance like 3 equals 5. So like 3 equals 5, well that makes no sense. That means that the original equation had no solutions. But if you end up with something like 3 equals 3, then that just means that your original equation had infinitely many solutions. Okay, so there are 6 little exercises that we want to solve. So we're going to solve the equations if it's possible. Here's the 6 equations that we're going to solve. If I was you, I would pause the video at this moment and try to solve them on my own. And then we'll just compare answers at the end. Okay, so hopefully you did pause the video and you have answers for all of these 6 questions. And let me go through the process of solving them myself. Okay, the first one. So on the first problem, so I'm beginning on the top left one. I want to isolate x. I want to leave x all by itself. So what I'm going to do, I guess the first step is I'm going to begin by adding 1 to both sides. Why? Because I have my x's on the left side of the equation and I'm going to keep them there. So I'm going to get rid of everything and send it to the right. Although it doesn't matter which side you end up with your x's on. Okay, so then I have 3/4 x is equal to, and now I gotta think, 7/5 plus 1. How do I make that happen? Let me make it happen over here on the margin. So 7/5 plus 1. Turns out I need a common denominator to add fractions. So I'm gonna do 7/5 plus, now 1 needs to become a fraction. And not only that, it needs to become a fraction whose denominator is 5. Well, that's easy to do. 5 is malleable. It's 5/5. Now that they have the same common denominator, I can add them. 7 plus 5 is 12, so 12/5. Okay, so 12/5. Okay, the next thing I want to do is I want to get rid of this 3/4 right here. I want to get rid of that 3/4 on the left hand side. How do I do that? And you might be thinking, well, divide both sides by 3/4. I could divide both sides by 3/4. Dividing, so for instance, if I divide by 2, dividing by 2 is the same thing as multiplying by the reciprocal of 2. So think about that. Dividing by 2 is the same thing as multiplying by the reciprocal of 2. So to divide by 2 is the same thing as multiplying by 1/2. So I am going to multiply both sides of this equation by the reciprocal of 3/4. So I'm going to do this. That's the same thing as dividing by 3/4. Dividing by a number is the same thing as multiplying by its reciprocal. Okay, so what happens here, since this is multiplication, this 3, that 3, this 4, and that 4 cancel, so this becomes x. And now I need to multiply 12/5 times 4/3. How do I multiply fractions? I do not need a common denominator to multiply fractions. All I need to do is multiply straight across. 12 times 4, 5 times 3, and then simplify afterwards. Another way to multiply is that even before I get into multiplying, maybe I could simplify first. What I notice is that, for instance, this 12 is the same thing as 3 times 4. And so then this 3 and that 3 sort of cancel each other out. This just becomes now 1. And so then it becomes 4 times 4, that's 16 over 5. Because it's then 5 times 1. So what I did there is I first simplified and then multiplied. But you could have just said 12 times 4, that's 48 divided by 15. Maybe you ended up with that, and that's fine. What you then want to do is simplify this fraction, and if you simplify this fraction, you should end up with this one, 16 over 5. That's the simplified form. If you were doing these problems in my math lab usually wants the simplified fraction. Okay, so hopefully we agree on that answer. Let's move on to the next problem. I'm going to solve this guy right here. What I'm going to begin doing first, before I do anything, is I'm going to distribute. I'm going to distribute 2, and I'm going to distribute negative 3, and then collect like terms. So I'm going to multiply 2 times 5, 2 times negative 3x, negative 3 times x, and negative 3 times 2. So that becomes 10 minus 6x equals 8 minus 3x minus 6. Okay, so what I notice is that I have 10 minus 6x equals, and now this 8 minus 6, those are like terms on the left hand side. So 8 minus 6 is 2, so 2 minus 3x. And now I have x's on both sides of the equation. It doesn't matter which side you leave the x on, pick a side. Right now I'm going to leave my x's on the right hand side of the equal sign. Why? Because I want my x's to be positive. So I'm going to add 6x to both sides. So I'm going to do this, plus 6x, plus 6x, then I'm going to do minus 2 and minus 2. Okay, so on the left hand side I should have 10 minus 2, that's 8. And on the right hand side I have negative 3x plus 6x. Well, that's positive 3x. And the last thing I'm going to do is divide everything by 3. Or multiply everything by 1/3. So we end up with x equals 8/3. Okay, so hopefully we agree on that so far. Let's move on to the third example here. Okay, so I want to get all of my x's on the same side of the equation. Right now I have x's on the left, I have x's on the right. So I'm going to get them all on the right hand side. So I'm going to add a 24x and plus 24x. And well, that cancels, and so then I end up with this weird situation here. 7 equals 17, which is well, obviously not true. So what does it mean about this equation? What does it, I mean, if we end up with this situation here, what are we dealing with? I guess what we're dealing with is there is no solution. That's what ends up happening. So if all of your variables cancel and you end up with a statement that is not true, like 7 equals 17, then that means that the original equation had no solutions. So hopefully we agree on that. Let's get on to the fourth example here. So I guess sort of the same thing. I gotta add 1/3 x to both sides, because I want to get my x's in the same side of the equation. And but if I do that, then I end up with this 3 equals 3. And well, yeah, okay, so 3 is equal to 3. But what does that mean about my original equation? Well, it means that it's infinitely many solutions. it doesn't matter what value of x you choose, it's going to satisfy your equation. So infinitely solutions. Okay, so hopefully we agree so far on these first 4 problems. Let's try the 5th one. Okay, so for the 5th one, I'm going to begin by distributing 3/4. So 3/4 times x and 3/4 times 8. Okay, so that becomes 3/4 x. And now, what's 3/4 times 8? You do not need a common denominator to multiply fractions. All you need to do is multiply numerator times numerator, denominator times denominator. Oh, but wait a minute, 8 is not a fraction. How can we make 8 into a fraction? Well, simple, just put a 1 underneath it. So 3/4 times 8 over 1. And now it would just be 3 times 8, which is 24, over 4. Yeah? So I guess that becomes 24 over 4. Or another way, but then you have to simplify this. And this, I guess, just simplifies to 6. Yeah? Another way to look at this is maybe let's first simplify and then multiply. 8 is the same thing as 2 times 4. So this 4 and that 4 cancel. This just becomes a 1. So then it's just 3 times 2. So 6. Okay. So 3/4 plus 6 equals 9. Let me subtract 6. So 3/4 x equals 3. And then the last thing to do here is to get rid of this 3/4. And what we said we wanted to do, the step necessary to get rid of the 3/4 is to divide by 3/4. But we also said that dividing by a number is the same thing as multiplying by its reciprocal. So I'm going to multiply both sides of this equation by 4/3. Okay? So then this says x equals, and then it's just multiplication of fractions. So think of 3 as 3 over 1. So 3 times 4 is 12 over 1 times 3. So 12 over 3. And that just becomes 4. Or another way to think about it is that this 3 and that 3 cancel. So this just becomes 4. So my answer for this equation is 4. X equals 4. Last one. Okay, so in this last example, the first thing I'm going to do is I'm going to distribute, in a sense here there's a -1 in front of this parentheses. Right here there should be a -1. And so I'm going to distribute that -1 to 2x and to -7. Okay, so 5x minus 2x plus 7 plus 3x equals 8 minus x. Next thing I'm going to do is collect like terms. So on the left hand side of the equation I have 5x minus 2x plus 3x. Okay, so 5x minus 2x is 3x plus another 3x is 6x. Okay, I am going to add x to both sides. So that says then 7x, and I'm going to subtract 7 from both sides. 8 minus 7 is 1. And so then I can conclude that x is equal to 1/7. Okay, so keep these two situations in mind. Anytime that you're solving an equation for one variable, and you end up with some scenario where it says something like 3 equals 5. Sorry, I'm trying to erase this. Then that means that your original equation had no solutions. If you end up with something like 3 equals 3, then that means infinitely many solutions to your original equation. Okay, so hopefully we agree on the answers here, and I'll see you in the next video for this section. So this is part 1. In the next part, we're going to be solving some application problems. Okay, thank you.